Hello. In our last video we looked at expanding brackets as well as factorising quadratics, and I said that I would show you an unusual method for factorising expressions of the form ax squared plus bx plus c. So let's have a look at this first one together. So there are four lines of working all together. In the first line we take the 2, which is the coefficient of the x squareds, and we remove it. And then we multiply the negative 21, the number at the end, by that, which gives us x squared instead of 2x squared. The plus x remains as it is, and we get negative 42 rather than negative 21 because we've times it by the 2. We then factorise x squared plus x minus 42 in the usual way, giving us x plus 7 and x minus 6. But you'll notice that I've left a gap in front of each of the x's, which will make sense when we look at line 3. So here the value of a, that was 2 in this example, is then reinserted into the spaces. So we get 2x plus 7 and 2x minus 6. We then look at each pair of brackets and we divide by any common factor it has. So 2x plus 7, the only common factor of 2 and 7 is 1, so we can leave it alone. Whereas for 2x minus 6, 2 goes into both the 2 and the 6, so we divide that bracket by 2 and get x minus 3. And 2x plus 7 times x minus 3 is the actual answer to the original question of factorising 2x squared plus x minus 21. We can check it. 2x times x is 2x squared. 7 times negative 3 is negative 21. And the x in the middle comes from doing 2x times minus 3, which is negative 6x. And 7 times x, which is 7x. And 7x takes 6x is x. So it works. I've put a tick next to it. Here are two more examples. So on the left, we have 4x squared minus 16x plus 15. Again, the a is 4. We remove that from that position, but we multiply c, the 15, by it, which gives us x squared minus 16x plus 60. We factorise that in the usual way, giving us x minus 6 and x minus 10. But again, I've left a space in front of each of the x's. And then a, which in this case is 4, gets reinserted in those gaps. Both brackets have common factors this time, so 4x minus 6 can be divided by 2 to give us 2x minus 3, and 4x minus 10 can also be divided by 2 to give us 2x minus 5, and 2x minus 3, 2x minus 5 is the correct factorisation for the original expression. Over on the right, we have 12x squared plus 7x minus 10. This time a equals 12, so we multiply c by that to get minus 120. Giving us a quadratic expression of x squared plus 7x minus 120. If we factorise that in the usual way, we get x plus 15 and x minus 8, and this time a is 12, and that gets inserted in the gaps. 12x plus 15 has a common factor of 3, so that gives us 4x plus 5 when we divide by it, and 12 and 8 have a common factor of 4, giving us 3x minus 2 when we divide by it, and a final answer of 4x plus 5 and 3x minus 2. But I was always advise you to multiply out the brackets you get at the end to check that they give you what you had in the first place. Please pause the video and try these 4 examples. Answers will be revealed in a different PowerPoint slide. We're now going to look at solving quadratic equations where you don't have an x squared and an x, or different variables, one squared and one isn't. But in this case, we have root x plus 6 equals x. And before we start, I need to emphasize the fact that root x in maths implies that it's the positive square root, not the negative square root. So root 25 only has a value of 5. If an equation says x squared equals 25, then the answers are 5 and minus 5. But if we just have root 25, that only has a value of 5, unless you write plus or minus in front of it, and then you can have both plus 5 and minus 5. So to solve the equation root x plus 6 equals x, it has been suggested that we write root x as u, and by doing that we actually turn it into a quadratic equation with a squared term and a linear term. So if we replace root x with u, then the first term is u, the plus 6 doesn't change, and if u equals root x, then x itself will be u squared. So we get u plus 6 equals u squared. If we take away the u and the 6 from the left-hand side and then rewrite it, we get u squared minus u minus 6 equals 0. So I kept the u squared positive to make it easier to factorise. That gives us u minus 3, u plus 2 in our brackets. and hence u equals 3 or u equals minus 2. But they are not the final answers, because the original question was in terms of x, and we used a substitution to replace it with u. But using the fact that u equals root x, we are now in a position to actually solve it. So 3 is the square root of what? Well, it's the square root of 9. So x equals 9 is a solution. However, although minus 2 squared does equal 4, okay, if we had root 4, that would have an answer of positive 2, as I mentioned at the beginning of this example, not negative 2. So x equals 4 is not actually a solution to this equation, because it doesn't give you negative 2 as the value when you square root it. Here are 5 more equations to solve by substitution, and I will do the first one with you and leave you the other 4 to solve for yourselves. So in question number 1, we have u equals 5 root u plus 6. So very similar to example with the root u in there. We've been asked to use the substitution u equals y squared. So the first term becomes y squared and 5 root u becomes 5y. So y squared equals 5y plus 6. We make the right hand side equal 0 by taking away the 5y and the 6. And then we factorize, which gives us y minus 6y plus 1 equals 0. And the solutions to that are y equals 6 or y equals negative 1. But the original equation was in terms of u, and we need to give our final answers in terms of u. U equals y squared, so we can square the 6 to get 36. Of course, you could square minus 1 and get 1, right? 1 is one of the answers, but the equation we are solving, again, it's the same issue as before. It says 5 root u, root 36 is 6, so that's absolutely fine, but root 1 is not negative 1, and hence 1 is not actually the solution, because it would have to give us a root of 1 in order to be a valid equation. And if we go back to the equation using 1 for u and 1 for the square root of u, we end up with 1 equals 5 plus 6, which is not true. So 36 is a valid solution. You get 36 equals 5 sixes plus 6, which is true, but 1 is not a valid solution. Please pause the video and have a go at the other 4 equations. And to finish off, 4 equations to solve. You can use whatever method you use, but again for 3 and 4 you may wish to use a substitution. Thank you very much. Thank you for listening.